This is Tim Hagerty with the Virtual Training Company. We're doing C++ fundamentals videos here, and we are now taking a look at dynamic cast operators. And in this case, we're looking at something called an upcast. Now, we already took a look at static cast operators, which we understand now are type conversions, casting, that are explicit. They're provided by the programmer, and there's no type checking going on. There's no runtime checking going on to make sure that it's a valid, sensible thing to do. This dynamic cast operator requires runtime checking to be enabled when you're compiling, and it will perform the runtime check to make sure we don't do something silly. So here we have a class B, and we have a new class C, which is derived from class B. So that's a box inside a box. Class B is a smaller box, and then Class C is a larger containing box, and then Class D is yet another larger item, which has starts out looking like a public C, the Class C, and then has its own methods and functions and such members added into it. So we're building a hierarchy here of B to C to D. Now in our function here, our void F, it is going to receive in a D pointer called PD, pointer to D. If we want to make a new C pointer, so that's the smaller class, fits inside a D, PC equals a dynamic cast to C pointer of a PD. That's okay because we're doing an upcast. We're moving from the larger box to a smaller box, and that is sensible. Something that already points to the large item can easily point to something that is within the box. All right, so that's good. Now here we're doing a B star, and that's a pointer to B. We want to make a new pointer to B, and we're going to cast a B from a PD, from a pointer to D. So we're making yet a smaller box. We're using a pointer to the larger outer class D, the derived class, which was derived from C, which was derived from B, which is the base class back here. And this is also okay, because B is an indirect base class, because we've worked our way back up the chain to get to the uppermost base class. So that works as well, and the compiler has protected us. Now here's using a void pointer. Here we have a class A and B, whatever they happen to be. Here's our new function, and here we have A star PA, that's a pointer to A, and it will be initialized with a new A. So we go out and create some memory and make this thing. Here's a B star. We're defining a pointer to B, and that's a new B. Go to memory again, create the thing, construct it, and so on. Now, here is a void pointer, PV. And PV is going to be equal to the dynamic cast void pointer of PA. That's just fine. Using void pointers is perfectly legal for all this. Now, there will be some runtime checking to make sure that this pointer can accept the conversion of this PA, and we know that it can because it's a void pointer, so that's fine. And here we say that PV is a dynamic cast of void pointer of a PB, also just fine. Using the void pointer is perfectly acceptable because we don't have the issues of assigning a pointer to the larger derived class into a pointer of something smaller, which it can't handle that. Now here's a downcast. This is going the other way, down the hierarchy. Here we have B, and then we have class D, which is derived from B. So D is the larger one, the containing class, and the derived, and B is the smaller. So here we make a new pointer to B, is a new D. Now that's not very clear, but it's all right. So we make this new D class and put it into PB, or the address of it into PB. And here PB2 is we make a new B class, a new base class, and assign its address into PB2. Now we're going to do our dynamic cast. So now we have a D star, which is a pointer to D, and we're going to cast a D star. We're going to take the pointer to B. Now it actually points to a D already, so that's okay. And we're going to cast that to a D pointer and put it into PD. Acceptable. But now we're going to get into trouble over here. The dynamic cast is going to try to take PB2, which we know from up here points to a B, a smaller item, and we're going to try to cast it to something pointing to the bigger box. That's not going to work because we can't take the internal base class pointer and try to cast it to point to something bigger than itself. The small box will not fit outside the large box. Okay, so we get PB points to a B, not a D. That's an error. So dynamic cast will return a null, and the operation will not complete. That's why dynamic cast is going to prevent us from doing something illegal. So that's dynamic cast operators: upcast, void pointers, and downcast.